Dear ladies and gentlemen, today we are showing you the balancing made with the DC23 vibration analyzer of the Association Vast Production. So we have here a system and a stand. We have a balancing machine or demonstration machine with two balancing planes with a number of bearing supports that we will try to balance. As the measurement system and the balancing system, we have DC23 data collector of Association Vast Production. We have two accelerometers. These are the accelerometers that can be installed on a magnet. We have it installed it in vertical position, in horizontal position. We have two channels here, and this is the connection. And plus we have TACO channel. This is phase reference TACO that goes down to here. This is a photo TACO probe. We can use laser, we can use photo. This one has two diodes. One diode is emitting infrared radiation, another is receiving it. So we can install it on a holder. The holder is adjustable. We have a mark. This is a mark on the shaft, and we get a signal from this TACO probe when the mark passes the phase reference TACO. So first of all, usually before we start the balancing, we will do some diagnostics. So we need to find out if we have unbalance here on this machine or not. To do this, we will make measurement of just normal auto spectrum. So we have the data collector. We will start the machine. And first what we do the measurement in the analyzer mode of the vibration. So we go to auto spectrum measurement, select something like this, 400 lines, linear millimeters per second, and measure it. Now we are measuring two channels on both vertical and horizontal, channel A and channel B, and here we see that the only line in the spectrum is the rotation speed. This is the rotation speed. This is channel 1, this is vertical, this is channel 2, it is horizontal. So in horizontal we have quite larger vibration, and it's about 6.5 millimeters per second, and this is ambulance. Otherwise we will have much more lines. And now we are ready to start the balancing. So we find out that this is the case of ambulance. So we can save these data for reporting. And now we go to the balancing. When we go to the balancing application, this one, we can set up the machine. To set up the machine, we use the button like new. We'll see it. Yeah, the create a new one, create machine. This is the machine name that we have to enter. For example, it can be machine name 789. This is the number of balancing planes. We can have with this data collector up to 4 balancing planes, but we have just 2 on my machine. This is the number of measurement points. We can have up to 5 measurement points, but let's measure just on 2. And this is directions. We can measure it in 3 directions, vertical, horizontal, and axial, in 2 directions or in 1 direction. Let's check 2. You see that we have a very big difference between horizontal and vertical vibration. That's why we will monitor both of these vibrations. So let's have 2. We can also create a scheme for the machine, and we can look at my machine. The machine is like we have a motor, we have disc, couple of bearings, and then we have another disc. So we can set up something like this here as well. So we have a motor, and we add it. After the motor we have the disc, like this. And here will be the mass number 1, balancing weight number 1. This goes to reports also. We can have it. Then we have bearing. So we can have the bearing here, like this. And this will be bearing 1, and we add it. Then we have the same bearing number 2. So this will be bearing number 2, we add it. And then we have finally the disc, like this, and this will be mass 2. This is just for, if we have this scheme, it is much more convenient and we will not miss where we measure and where we apply the loads. So we save it, and then we can go next to do the measurement. So first of all, we set up the vibration measurement. The measurement units is millimeters per second, or we can use any other measurement units. Let's make millimeters per second. Rotation speed is RPM, or it can be Hertz. Let's stay with RPM. Detector is RMS or peak, peak. RMS is the standard one, and angle reading direction with rotation or against rotation. So we stay with rotation, for example. We can also select against rotation. Now we need to make the initial vibration measurement. Bearing number 1, bearing number 2, vertical, horizontal, vertical, horizontal. This is the assignment of the channels. So the channels are assigned like A and B. These are the two channels. We can also look at the scheme here. So these are the measurement points. Bearing number 1, go back like this, install the accelerometers. First channel is vertical, second channel is horizontal. So these are the two channels that we are going to measure. We start the machine. So the machine starts, and now we start the measurement by pressing the measure button like this. So now we measure amplitude, phase, and the rotation speed for these two accelerometers. It will stop the reading as soon as it reaches a good quality of the measurement. So amplitude, vertical, horizontal, phase, vertical, horizontal, and this is the error. The error is 0, so we have very good measurement. Now we put the sensors to the second bearing support, so vertical, horizontal, like this. These are assigned to channel A and B, and we press measure. So the measurement is done. We switch off our machine. What we can see here? Here we can see that we have much more vibration in horizontal and much less in vertical. We take the largest vibration level that we have. This is right now on bearing 1, and I would suggest that we start balancing with this plane close to B1, and the plane here is mass 1, so with this one, and we go back. By the way, here you can also see the vibration that we have measured. So this is the amplitude and this is the angle of vibration reading. So let's make some analysis. The largest vibration is in horizontal direction and its phase is 64 degrees. Let's go and look at our machine. So this is this position, so this sensor, horizontal. We align, mark, accelerometer, mark, and phase reference tackle on one line. If we select it on one line and we measure it in millimeters per second, this phase will show us the heavy point. The heavy point with rotation. Our rotation is in this direction, so in this direction. So it is the heavy point will be 64 degrees from here. So we need to install, so this is 1, 10, 20, 30, 40, 50, 60. This is the heavy point approximately. And we just take it opposite opposite, like this. Here is the light point, and I would suggest that we apply to here, to 220, a mass. This will be trial mass. I don't know what is the amount of this mass, but the angle to where I would suggest that we need to install the weight is approximately here. So we will start the balancing with installation of this trial weight. We go next to here, and this is the choice. If we are balancing this machine for the first time, we can go to the full balancing and go with some trial weights. If we have balanced it already, we know the influence coefficients, and we can go with the balancing by influence coefficients, or so-called trim balancing. So we start with the full balancing and go next. It asks us where we are going to install the trial weight. So the trial weight, I suggest that we go to the mass 1, so plane number 1. We can select it here. We can install it either on 1 or on 2. So we select 1. The amount of mass can be calculated here. This is not balancing. This is actually estimation of trial weights. So we can go here, and it asks rotor weight. Okay, I have about 35 kilograms of rotor weight. Then radius, maximum vibration amplitude in millimeters per second. Installation radius. This is what I have here is 120 millimeters. This is the maximum vibration that I have measured. This is the rotation speed, and here we press calculate. So about 10 grams. About 10 grams. This is the amount of weight that it recommends for the trial weight. So we go back and we enter the parameters. We enter the parameters of the trial weight. So we go here and enter. To do this, we take our scales like this. We start it, and we have some mass here. Well, it's about 7.55 grams. Let's try this one. 7.59 grams. So we 7.59 grams. Yes. Angle. We have estimated that the good angle will be 240, like this. And we can start measurements. So bearing number 1, vertical channel number 1, horizontal channel number 2. So what we do, we install the weight. This is the trial weight. These are the accelerometers, channel number 1 vertical, channel number 2 horizontal. We start our machine. And we press measure. Now we put the sensors on the second. And we press measure. So the measurement is complete. What is the most important is the sensitivity. This is sensitivity. It means that vibration have changed with the installation of the trial weight. So we have installed trial weight and we have changed the vibration by this trial weight. So you remember it was something like 6 millimeters per second, now it is 4. At least we did not increase it, and this is quite a good result. Now we can go next and calculate what we can do with this balancing plane. So we go next, and it says that, gentlemen, please install this number of grams into this angle of phase. And in this case you will get these vibration levels for the two planes. So you see that with this single mass in one plane we can correct all the 4 measurement points and the 2 bearings. And this will be finished. We will not need the second mass. So we can try doing it. Otherwise, if you are not satisfied with these results, you can add the next trial weight. So then you select the next trial weight and install it on the second place. So previously, if we go back, we have installed this mass and say that this is temporary. So we have to remove this mass. So we have to remove the trial mass, and we do it. So we remove the trial weight. Yeah, and then we install, instead of this trial weight, it was 7.6 grams on 240 degrees. Instead of this, we install approximately here 4.5 grams on 250 degrees. So we weighted, and this is 4.56 exact feet, nearly exact feet, and we install it on 250 degrees. So we calculate the degrees. We have these threads on each 10 degrees. Here, this is 250 degrees. Okay. So actually here we have the choice, either next mass or we do the final measurements and see if we will reach these numbers. So we go to the final measurements. Here it asks, did you remove the trial weights? Yes, we have removed them. And what you put there. So here it is very good to tell it what exactly we put there. So it was something like 56, and it was at 50 degrees. Okay, this is what we installed. And now we take the bearing 1, vertical, horizontal, and start the measurement. So this is the bearing 1, vertical, horizontal, and we start the measurement. This is the vibration levels. Then we put the sensors to a different position, to the second bearing, here, and we start the measurements. The measurements are finished, and what we see now is that we have the maximum vibration of 1 instead of 6.5 or something like 6.8 that was initially. So we can calculate now the correction weights. So it suggests for us to put 0.675 grams on the same angle. So we need to add some weight, and in this case vibration will be even less. If it is possible, we can install this, but if the vibration that we reached already is good enough for us, then there is no problem, we can just finish the balancing. So this is the measurement results that we get. Vibration is quite small, and now we can just finish the balancing. Finish the balancing. When we press finish the balancing, we get the balancing report. So this was what we have done. This is our machine scheme. This is the vibration that we have measured. This is all the measurements, and this is the influence coefficients that we can use next time. So initially we had the vibration about 6.7 millimeters per second. Finally, we have get the vibration of this is trial run. We get the vibration of about 1 millimeters per second. So thank you very much. This was the vibration by the VAST DC23 data collector. If you have any questions, you are welcome in the comments. Thank you.